Hello friends, today we will learn about virtual functions, virtual destructor, and how we can override a method in a derived class using virtual functions. So let's start. So this is what my base class looks like. It's having a constructor, destructor, and a function which returns nothing. So void do something and it takes no arguments. So this is the definition here. I defined here. The constructor is there, just a logging, and a destructor also just a logging, and a function do something, and just log is there which says in base do something. So now let's first inherit this base class. So let me make a new class called name as derived, and it publicly inherit base. Okay, so let's give the derived here the constructor, the destructor, and the same method I would be keeping it in the derived class as well. Okay, so this becomes my derived class. Now just to define it, all the same methods and the constructor and destructor, I just define it like this, just a logging, derived constructor, and here derived destructor, and then void derived do something, the method. Okay, here also I'll do logging in derived do something, so here comes my derived class also. I'm publicly inheriting from base. I have a constructor, destructor, and a method. So you see the do something in base as well and in derived as well, and I'm gonna override it. Okay, so how we can do it? So first let's see without virtual keyword what's the behavior. So let's have a main here, and we know that a polymorphism, a base class pointer, can point to an object of its derived. Okay, so now I make an object of derived class here, and I make a base type pointer to point to this object. Okay, now I call to something, sorry, it's pointer, so it would be like this, to something, and then I perform some operations, and then when I'm over, I call a delete on B to call the destructor and to free up the memory. So, and this becomes my code here. Okay, so now let's run and see what's the behavior now. So let's recap quickly. So this is my base class, the definition of all the constructor, destructor, and the functions do something, and then the derived class which is narrating publicly from base, and then the constructor, destructor, and again a function which a method which is the same name and no arguments. And here the definition goes, and then what I'm doing is that I'm constructing a derived object, and I'm keeping a base pointer to point to the derived object, a simple polymorphism. Okay, and now I'm calling do something method using the base pointer. So now let's see, do something is called of derived or of base, that we'll see just now. And then when I'm done with that, I'll just delete the object that B is pointing to. Okay, so now let's compile it quickly. So it's saying, okay, so did I make some spelling? Okay, yeah, derived, yeah. So let's compile it. Okay, yeah, so I need to declare it public as well, because by default it is private. So let's compile Yeah, perfect. So now let's compile it. So now you see that a base constructor is called and derived constructor is called. Okay, so now we know that the construction always happens from base to derived, so that's perfect. Base constructor and then the derived constructor, my object is constructed. Good. And now when I call do something, you see that the in base do something is called. That means the do something of my base class is called. Okay, so why is this so? Because do something is statically typed, or you can say a statically binding happens, and it's typed into a type base. When you're calling you say with a base pointer, then there is a static binding now, because you haven't declared do something as virtual. So static binding has been done during a compile time, and when you call do something upon with using a pointer of type base, so the do something defined in a base class would be called, as you can see here. Okay, because of static binding now. Okay, and the method you cannot override, because you can see the object is of derived, but since the do something is statically bind with a type, so if the type is of type base, so the do something of base would be called here. Okay, so you cannot see a method overriding here. Okay, so now, and one more thing, second thing is that you see that the base destructor is called and the derived destructor is not called, and hence this could possibly may lead to a memory leak if something you allocate a memory in a derived class. Okay, so we have to make sure that and when you're calling delete on a base pointer, then your derived destructor should also be called. Okay, so two things we have to make sure. So now I want do something to be overridden, and I want do something of derived class should be called, because an object is of derived class. Okay, so we want to skip this static binding and we want a dynamic dispatch. So instead of whatever the base pointer is used, it should always be a dynamic dispatch. That means whosoever object would be, that method should be called. Okay, so now if you declare a virtual here, so what happens? C++ compiler does not statically bind it to a base type or the type. Okay, so what it does, it have a internal mechanism of virtual pointers and v tables in which a dynamic dispatch happens. Okay, so do something is not statically binded now, it would be all dynamic dispatch now. So whosoever the object would be, that do something would be called. So like you can see, if the object is of derived now, so it would be seen that if the object is derived, then do something defined in the derived class would be called now. Okay, so now let's, after declaring the function do something is virtual in a base class, let's compile it again and let's run. So now you see here that a base constructor, then a derived constructor, perfect, and now in derived do something is called. Okay, because I declared the do something in a base as virtual, so of course the internal mechanism of v pointer and v table make a dynamic dispatch happens, and whosoever the base pointer is pointing to, it automatically calls the method of derived class. Okay, but now still the problem remains is that when I call a delete on base pointer, the derived destructor is not called. So again you have to make the base destructor, the destructor defined in a base class, also as a virtual. So now, so we make it a virtual here. Okay, so now if I again compile it and let's see the output. So now perfect. So the construction happens from top to bottom, and then the dynamic, due to the dynamic dispatch, the do something is overridden and the do something defined in a derived class has been called, and now the destruction happens, the derived destructor from the bottom, the destruction happens. So now the derived destructor is called and then the base destructor is called. Okay, so we have to make sure whenever you are calling a delete on a base class pointer as here, then define the base, then define the destructor, defined in a base class as virtual as well, so that the destructor of a derived class is called first, and then the destruction goes up. So make sure about this, defining the virtual destructors. Why is it very important? And I hope you learned good things about polymorphism and virtual functions. See you in the next video. Thank you.